Charles de Coulomb studied the interaction of forces between charged particles in the 1700s. He deduced the law that governs the electrical attractions and repulsions. So let's say we have two positive charges, Q1 and Q2, and they're separated a distance r. It can be shown that the electrical force on one charge from the other charge is directly proportional to the product of charge 1 and charge 2, and inversely proportional to the separation distance r squared. The proportionality constant K has been determined to be equal to 1 over 4 pi epsilon naught. Now this is a little bit complicated, and recently the College Board has simplified the version to simply be K, like in many textbooks, which is equivalent to, well, technically it's 8.99 to the power of 9 Newton meter squared per Coulomb squared. I've written as 9.0 because that is what is written on the AP formula sheet. The SI units of this force, as expected, would be in newtons, and the units for distance is in meters, and the units for Q1 and Q2 are the units of charge, and they are in coulombs. Like all forces, we see that they are vectors, and they point along the radial direction that is either away or towards. For two positive charges, the force of one charge on the other is directed away. Thus, if they were to be released, they would move away from each other, and hence like charges repel. These forces, F2 onto 1 and F1 onto 2, are equal in magnitude and opposite in direction, even if Q1 and Q2 are not equal in size, and thus they obey Newton's third law. For every action force, there is an equal and opposite reaction force. In the situation where we have one charge that is positive and the other is negative, the force on the positive charge is towards the negative charge. If they were to be released, the electrical force would cause them to move towards each other. Thus, opposite charges attract. You will note that in my formula for Coulomb's law, I've used absolute value signs. This is because I would like to find the magnitude of that force vector. Some books will simply use F equals K Q1 Q2 over R squared, and so when one charge is positive and the other charge is negative, you'll get a result that is negative, which is indicating that you have an attractive force. I prefer not to use this method and simply remember the basic law of electrostatics, that like charges repel and opposites attract, and then show the direction of the forces in the diagram, or simply write it in words such as right, left, up, or down with your answer. If there are more than two charges present, the total or net force acting on one of the particles is simply the vector sum of all the forces acting on that particle. This is known as the principle of superposition. For the example here, you can see that we'll have a force of 1 onto 3 repulsive away. So I'll draw that force. This is the force of 1 on 3. We have a force of 4 onto 3 pushing it to the left because it's repulsive. And we have also a force of 2 onto 3 going this way. And we have 3 different forces acting on charge Q3. The total or net force acting on this charge Q3 is the vector sum of all 3 of these individual forces.